Intersection of solids. Intersection of solids. In designing mechanical parts or pipelines, a variety of shapes have a line where they meet. It is important to have an accurate view of this line. We'll be focusing on prisms and pyramids, cylinders and cones. So why intersection? So in many industries, say the oil and gas or the water industry, pipes have to be joined at particular angles. So if a welder has to join two pipes at a right angle, where would he cut the pipe so that the edges meet and they can be welded seamlessly without any leaks? If you are designing a new addition to your house, where would you break the wall and how big would you make the hole to accommodate this new addition? These are important questions in intersection. So there are some possibilities where solids meet. So you'd have two similar solids, say a square and a square, two dissimilar solids, say a rectangle and a cone, and then you have varying angles of intersection. So some meet at right angles, others would meet at an angle that would be off the axis. And then where these solids meet, their axes might be different. So in this example, you have two prisms. So you can see that the prisms intersect at right angles to each other. This in the front elevation here and the end view on our plan. So in the end view and the plan, you could see all the curves of intersection. So where they meet, you don't see the actual curve, but the view, it is behind the actual solid prism. So if you trace the ends, in this example, if you look at A semicolon and you pull it across, it will meet at the edge there as well as the back. So you could trace them across from the end view and the plan. So where they intersect on both is the point of intersection. So this one is a simple one because it's just straight lines or a regular solid. Here you have two dissimilar solids. So you have a cylinder and a cone meeting at right angles. So to trace the path of intersection, you divide the base of the cone into, in this example, there's 5 different parts, and then at the point where it's divided, it traces up to the tip of the cone. So in the plan view, you could see the curve of intersection here, and then you trace each of the points back up to the top. So in the middle would be on the ends of the cone, and that would meet exactly on the edge of the cylinder. Then if you go to the second point and you go up, where the line goes up to the point where it intersects the two lines is the point of the curve. So you continue to trace that path as you go along. Then you have varying angles of intersection. So in the other two examples, you could see them meeting at right angles to each other. But in this one, it's off the central axis, so it's not 90 degrees to each other. So, but the construction is very simple. You divide the curve into a number of equal parts and you trace the path down. And where you, on the plan view here, where you see the curve intersecting, you trace the same points backward. So if you divide this into 5 equal parts, you divide here into 5 equal parts. You trace them to the cylinder and then back up. And the last one is different central axes. So you have a cone and then you have a square prism. So the center of the cone falls here, but the center of the prism falls on this side. It is a similar construction in that you divide in this example, you divide the cone base into 8 equal parts, and then you trace all them to the center, and where the lines intersect the prism, the square prism, you trace it upwards. So the same, let's say A on the edge here, A on the edge goes up to the top, and then in on the plan to 1, and then goes up, and where the line goes up to the cone and the prism meet is the first point of intersection. And then you do it for a number of points along the prism. The more points you have, the smoother the curve. So that's the end of the presentation. always note that I cover the basics of it. Use your textbook, so chapter 12, intersection of irregular solids. Have a look at it. It will have a little more detail. It won't have the exact problem you're facing, but it will have similar examples that you could draw reference from. So please use the book, read through it, see the construction, see the different types of intersection, and use it as a guide.